What's up guys, this is Massey. Welcome to another video. In this video I want to talk about finite differences of polynomials. For a polynomial function of degree n, where n is the positive integer, the nth differences are equal or they're constant, have the same sign as the leading coefficient, and are equal to a times n factorial. What does that mean? A is the leading coefficient and n factorial is n times n minus 1 times n minus 2 and so on until 1. So now I'm going to give you some examples to find out the finite differences. So we're going to have a table of values, and based on this table of values we're going to predict the order of the polynomial, and we're going to find out the leading coefficient of this equation. Let's start with the first example. This example, it says each table of values represents a polynomial function. Use finite differences and determine the degree of polynomial function, the sign of the leading coefficient, and the value of the leading coefficient. So we have x values and we have y values, or f of x. Negative 2, 1, negative 1, negative 3, 0, negative 1, 1, 7, 2, 21. Now if you find the differences, 1 subtract negative 3 is going to be 4. Negative 3 subtract negative 1 is going to be negative 2. Negative 1 minus 7 is negative 8. 7 minus 21 is going to be negative 14. So they are not obviously equal. So our polynomial is not first degree polynomial. It's not a linear function. So let's construct the second differences. 4 subtract negative 2 is going to be positive 6. Negative 2 subtract negative 8 is going to be positive 6. Negative 8 subtract negative 14 is going to be positive 6. So as you see here, the second differences are equal, and it's equal to 6. So second differences are equal. Therefore, the polynomial is the second degree function, which we call it quadratic, and definitely the leading coefficient is going to be positive, and as we said, 6 is going to be equal to a times n factorial. N is the degree of function, which is 2. So 6 equals to a times 2 factorial. So a will be 6 divided by 2 factorial. 2 factorial is 2 times 1, which is 2. So 6 divided by 2, a is 3. So the leading coefficient is positive 3. Now let's take a look to the next example. So again, we're going to have a table of values, x and f of x, or y, basically. So what I'm going to have here, I have negative 2, negative 13, negative 1, negative 4, 0, 1, 1, 2, 2, negative 1. Then I subtract these numbers. Negative 13 subtract negative 4 is going to be negative 9. Negative 4 subtract 1 is going to be negative 5. 1 minus 2 is negative 1. 2 minus negative 1 is going to be positive 3. So as you see here, these four numbers are different. So the first differences are different. It means that definitely our polynomial function is not linear, or it's not first degree. Let's construct the second differences. Negative 9 subtract negative 5 is going to be negative 4. Negative 5 subtract negative 1 is going to be negative 4. Negative 1 subtract 3 is going to be negative 4. So again, the second differences are equal, and it's equal to -4. So second differences are equal and they are -4. Therefore the polynomial function is second degree function, which is quadratic, and the leading coefficient is negative. So -4 equals to a times n factorial, which is going to be 2 factorial again, like the previous example. 2 factorial is going to be 2, so a is going to be -4 divided by 2, which is going to be -2. So leading coefficient of this polynomial is -2. Let's take a look to the next example. So next one is x and f of x, -2, -1, 0, 1, and 2, 11, 7, 3, -1, and -5. So we construct the first differences. 11 subtract 7 is going to be 4. 7 minus 3, 4. 3 minus -1, +4. -1 minus 1, +4 as well. So these are all equal. So since first differences are equal, so the polynomial is linear, first degree polynomial. Four will be equal to a times n factorial. So it is going to be a times 1. So a is going to be 4. So we can say 4 is the leading coefficient. So this example now, it is -3, -2, -1, 0, 1, 2, 3, and we have these numbers in here. Let's take a look and have first differences. So now second minus first one we do. Let's do it this way. It's gonna be 38. 3 subtract -11 is gonna be 14. 5 minus 3, 2. 7 minus 5 is 2. 21 minus 7 is 14. 59 minus 21 is 38. 14 subtract 38 is -24. 2 minus 14 is -12. 2 minus 2 is 0. 14 minus 2, 12. 38 minus 14 is going to be 24. -12 minus -24 is +12. 0 minus -12, +12. 12 minus 0, 12. 24 minus 12, 12. So we can say that the first differences are different, the second differences are different, but the third differences are equal. The third differences are equal, and it means the polynomial is a cubic function third degree function, and it is equal to 12, which is a times n factorial. Now n is 3, so 12 equals to a times 3 factorial, which means that a is 12 divided by 3 factorial. 3 factorial is 3 times 2 times 1, which is 6. So 12 divided by 6 is going to be 2. So the leading coefficient is 2, positive 2. So that's how do we find out the order of the function or degree of the function and leading coefficient based on finding the finite differences of table of values. I hope you enjoyed this video. Please leave me a comment if you have any question, and please don't forget to subscribe to this channel. You can have access to many other videos related to math, chemistry, and physics. Thank you for watching and have a great day.